how do we get from adaptive signatures to discrete log contracts?
So we mentioned that these adaptive signatures are like a signature encryption, right? And this is basically the way that discrete log contract uses them. So this whole like you reveal the locking thing, locking key when you unlock it doesn't really apply here. So we're just talking about encryption. And so the very simple way it works is we both put money into a transaction, we'll put money into an output. We're making a bet. Let's say it's on the NBA or on the price of Bitcoin or whatever. We both decide what are the conditions of the bet, and in what conditions, what apportionment of funds there is. So what portion of the funds do I get? What do you get? Under which condition? And so these conditions are expressed as, let's say, public keys. Each condition is like a public key where only the oracle knows the secret key. And so what we're going to do is under each condition, we're going to take the public key associated with that condition, and we're going to encrypt a transaction that spends for our joint output and apportions the funds according to what we've decided. And that's all we do. We create a joint output, we both fund it, we encrypt all these signatures to all these different public keys. Eventually the oracle will reveal one of the decryption keys, the secret key for one of those public keys. We take that secret key, or the winner, whoever feels enthusiastic about that being the outcome, says, yeah, I'm glad this happened. It decrypts the transaction they have and publishes on the blockchain. So we have this very simple 2 of 2 multi-sig, which when we have Schnorr will just be a single Schnorr public key. And then once the bet is settled, we have, once again, a single transaction spending it, from it looking very normal and boring. But off-chain, obviously, there was this big set of transactions we both jointly signed to map these conditions from the oracle into onto the particular portion of funds we wanted. Unlike Ethereum, let's say, because Ethereum has a lot of oracle stuff going on, all this data, unfortunately, because it makes my skin crawl to think of all the data that goes onto the Ethereum blockchain. So all this, when you in other systems, the people that have decided that the way to do it is to put actual data onto the blockchain, and you can have your smart contract can call and request data about this event, and some oracle will actually insert it on the blockchain, meaning your blockchain is full of data about the real world, like it's like a database about what happened, which I guess could be cool in one way, but from our principles in Bitcoin is very not cool. Instead of having that, we have just these 2 boring transactions on the chain once again, even though we mapped this with the help of the oracle, this complicated real world phenomenon. We mapped it onto the blockchain using 2 very normal boring transactions, just using cryptography to bridge these adaptive signatures to do this, to bridge the gap